My name is Anak Mattiew, student under supervision of Dr. Nabilah Binti Kasim, and I will present to you my research regarding passively Q switching of erbium dot fiber laser using graphene as saturable absorber. Laser is a device that uses the principle of stimulated emission to produce light and will use for scientific research before any other application. Laser stands for light amplification by stimulation emission of radiation. The concept of stimulation emission for laser was introduced by Einstein as he laid its foundation in 1917. Q switching, however, was first proposed by Gordon Gould in 1958, and it was demonstrated and independently discovered by R.W. Hellwood and F.J. McClung using electrically switched Kerr shutters in a ruby laser. Q switching is a technique that produces pulse output from a laser by modulating the intracavity losses. In 1980s, a development of low-loss rare earth dot fiber lasers led to the first report of fiber lasers emitting output of the order of a few megawatts. Thanks to the development of lasers in science, intensive research was carried out to achieve an average power output close to kilowatt range. My motivation to do this research is because pulse lasers are useful in many applications where continuous wave lasers do not work, because the energy from a pulse laser is compressed into small condensed packets. This concentrated energy is greater in a laser pulse than the natural strength energy coming from a continuous wave lasers. Compared to the actively Q-switched fiber laser, which need additional external switching electronics, passively Q-switched fiber lasers have attracted more attention owing to the advantages of compactness, low cost, and simple configuration. Therefore, this project is conducted to design an effective and efficient passively Q-switching erbium dot fiber laser. The Q-switch pulse will be using different pump powers with their respective wavelength from a 980 nanometer laser diode source by increasing it from a certain range to observe the bandwidth, wavelength, and output power, and etc. The proposed project is to achieve good repetition rate and pulse width and to fabricate graphene as saturable absorber. Graphene was first discovered in 2004, and the reason I decided to use it is because of its intrinsic optical properties. Graphene offers outstanding properties including a fast recovery time, large response bandwidth, and simple fabrication. To test the passively Q-switching graphene saturable absorber is to construct an erbium dot fiber laser with a cavity configuration which is made out of the standard fiber optics components such as the WDM wavelength division multiplexer, coupler, optical isolator, and erbium dot fiber (EDF). The output spectrum is analyzed by an optical spectrum analyzer (OSA). After that, repetition rates and pulse trends are analyzed by a digital oscilloscope and a photodetector. Laser diode control are employed to simultaneously monitor the optical spectrum and the temporal evolution of the output pulse trend. Therefore, before ending my presentation, I would like to highlight the significance of this research, which is to emphasize the importance of pulse laser in this day and age, is that Q-switching have been widely applied in diverse fields such as laser processing, remote sensing, medicine, and telecommunications. That is all I can present in this 3-minute presentation. Thank you. Have a great day.